All right. So today we're going to talk about traction quite a bit. We're going to start talking about traction. We're not going to talk about setup. We'll do that later. The reason is first we're going to figure out what the best line is around certain tracks and why. So we're going to talk about some of that stuff. And when you get to a new track, how do you plan your lines? How do you stay on them will be the next part. We'll start with traction because traction governs how fast you can go around a circuit. And the fastest racers will make the best use of traction. So it's not just about going on the edge, but also about how well you manage your car on that traction limit. So we'll start with cornering power. Some of you might have taken some physics. I'm talking about the radius of a corner that you can do for a given amount of traction that you have. It's proportional to velocity squared. So what that means is your speed. If you go fast, you can go as tight. And what that means, this squared is actually pretty important, because if you go twice as fast, it means that your corner has to be 4 times as wide. Right? So if we start off, I'm just going to map something here. So if we say we go 10 kilometers an hour, we'll call that 1 meter, let's say, of your corner radius. So if at 10 kilometers an hour you can go at 1 meter, what that means is that if you go 20, you have to go 4 times as wide. There's your point. If you go 30, you go 9 meters. 40 is going to be somewhere up there. We got a lot of hairpins here, so we'll take a look at a hairpin. How do you get around? So, plastic hairpin. Four in the middle, and you're coming in this way. So for the first bit of the sample here, what we're going to do conveniently, I made it about the same as the 20 arc here. So we're going to try to carry as much cornering speed as we can throughout that 20 arc. And we're going to map that into so we'll go 20. We're going to do exactly half a circle. And at this point, right from here, right to the end there, we are at the edge of traction, right? There's no more traction available in the tires. And up to that, so we're going to do some braking, because we're going to start off somewhere around here. Go say 40. That's about the speed of a stock car. And we're going to brake down to 20. Then when we're done, we're going to accelerate. It'll probably take you about twice as long to accelerate back up to 40. So that's one way to take a corner. And remember what we're doing here, right? We're going at constant speed at 40. We're at the traction limit braking here. That may be actually shorter. It looks kind of long to me. We're at the traction limit braking. And then here, we're going to heave it into the corner. Right there's your transition into the corner. And now again, we're going to be at the traction limit, as I said before. Doing 20 around the corner, and then we pin it. So at the first part of this acceleration you get, we're going to be kind of at the traction limit. We're running rubber tires. You could break the tires loose, right? But as you keep accelerating, you just don't have to torque to keep spinning the tires. So you're just going to accelerate smoothly afterwards. Now this is the ideal line if you have a car that has very low power to weight ratio. So if you're driving a bus and you have the power of a Mini, you'd want to carry as much speed through this corner as possible, because otherwise your acceleration to get back up to speed if you went any slower would be way too long. And a couple of other problems with this is this transition here. If you decided you're going to start your corner right there, and you're going to dedicate all of your traction to turning once you start the green line there, you're going to have to make your transition pretty quickly. So you go full brakes to here, where you crank it in, and then you don't brake anymore, right? That transition is very short. And it gives you very little room to adjust for the corner. I mean, at this point, you're already committing to what you're going to be looking at over here and over here. You probably have very little room for adjustment. So we're going to try something else. Draw another corner. Get about the same size. And this time, because our cars have a very high power to weight ratio, scale-wise, they accelerate faster than Formula One. Like if we scaled them up, they would be the fastest thing, fastest car on the planet. So what we can do is we can give up some of this cornering speed. Look, it's taken us a long time to get around that corner. That's quite a wide arc. So we're going to tighten it up. And when I say that to some people, and I say tighten it up, they'll start their corner here, and then they'll still draw a perfect circle. I'll do that here. I say tighten it up. They'll start their corner here, still do a half circle, and then that means tight to some people. What we're going to do is we're going to slow down around the apex. And so we're going to go, instead of 20, we're going to follow a 10 arc. So let's do that. But we're not going to follow it for too long. Right? We don't need to go this big. So we're only going to follow the 10 arc for a very short period there. And then we're going to decelerate into the corner smoothly. So we're going to do our 20 after that. 20. That's going to be something like that. And then 30. 30 is going to be a wider corner. And then go 40. Then we're going to do the same thing on the other side. We're going to get into the corner smoothly. We're going to slow down more, but now we can start applying gas, right? Here we have to wait until way in at the end of the corner to start applying gas. Here we're going to start getting on. Do a bit of a 20 there. Accelerate further. What we end up doing here is doing two things at the same time. So we're on the brakes. Well, in our cars, probably not on the brakes. You probably have some drag brake in there, might touch the brake a little bit. But you're on the brakes at the same time as you're turning. And so that's why you kind of get this gravel-ish. I think the important thing to realize there is that you're still at the edge of traction. So if we draw, it's supposed to be a circle. Draw the traction circle. What this circle represents is the amount of traction that the tire has. So when you're accelerating, this is as much accelerating power that you can apply to the tires before you start losing traction, right? Braking, it's It's going to be about the same.